Assalamualaikum and greetings everyone. Today's topic is on operations involving vector valued function. Okay, let's say you're given two vector functions f and g with parameter t and a scalar function phi t. Then here we have 1, 2, 3, 4, 5 operations. The first one is adding two vector functions. Second is the difference between two vector functions. The third here is multiplying a vector function with a scalar function, and we can also find cross product between two vector functions and also dot product between two vector functions. The first four operations will give you vector function. The result will give you a vector function, but the last operation here will give you a scalar function, not a vector but a scalar. Okay, let's look at example. So here in this example, we're given two vector functions f and g, and we are asked to evaluate 1, 2, 3, 4 examples here. Let's start with the first example where you want to add two vector functions. Okay, so here we have vector function f. Here I'm using pointy notation, pointy bracket notation instead of sum of the standard unit vector I, j, and k, just to save some space. Alright, so when you want to add two vector functions, so here we have this is equal to ft plus gt. Okay, so the components of f is t squared I, t minus 3j plus 3k, and then you want to add that to vector function g. Okay, so what you do is you add the x component with the x component, so we have t squared plus et, and for the y component you add the y component of f with the y component of g, and for the z component you just add the z component of f with the z component of g, and then simplify them. Okay, so we have t squared plus et, and here we have t minus 3 for the y component and 3 plus t for the z component. So you can write it using the pointy bracket notation, or you can write it as a sum of the standard unit vector, which is I, j, and k. So you can write it this way with the sum of the standard unit vector I, j, k. Okay, like so. Alright, so either way, that's fine. Right? Okay, the second example, the second question is we want to multiply vector g, vector function g, with a scalar function et. Okay, the second is when I multiply the scalar function et with vector function g. Okay, so we have et multiply with vector g, which is eti plus 0j plus tk. So what you do is you multiply the x component with et, y component with et, and the z component with et. So you just multiply each component with scalar function et. So simplify them, we get e2t for the x component, 0 for the y component, and tet for the z component. Okay, now let's look at the third question. The third item is where we want to take the cross product between two vectors f and g. Now if you recall, for the cross product is okay, here for the cross product between two vectors a and b, here we need to find the determinant of a 3 times 3 matrix, where the first row are the component of the first row would be the standard unit vector I, j, and k. The components of the item in the second row would be the components of a, and the item in the third row would be the components of vector b. And then here we have the sign alternate, plus, minus, plus, and the x component would be the determinant of a 2 times 2 matrix, where you cross out the first row and first column, and the components of y would be the determinant of a 2 times 2 matrix, where you cross out the first row and the second column, and the third is when you cross out the first row and the third column. Okay, let's look at our example. Okay, now we want to take the cross product between f and g. Okay, so that would be f cross g, vector f cross vector G. So this is really a determinant of a 3 times 3 matrix. First row are the standard unit vector I, j, and k. Second row would be the components of f, which is t squared, t minus 3, and 3. And the third row would be the components of g, which are et, 0, t. And remember the sign alternate. So here we have plus, minus, plus. Okay. For the x component, it's going to be determinant of a 2 times 2 matrix. The components or the elements in the 2 times 2 matrix is obtained by crossing out the first row and the first column. So you end up with a 2 times 2 matrix, and the elements are t minus 3, 3, 0, t. Okay. And for the y component, remember here the sign alternate, the next one is minus. It's going to be a determinant of a 2 times 2 matrix as well. But the components now would be, or I'm going to cross out this first. Okay, so the components of the second 2 times 2 matrix here is where you cross out the first row and the second column. So now the components for the determinant that we need to find is t squared 3 et t. Okay, now for the z component, now the sign is plus. So we have plus sign. And then we need to find the determinant of a 2 times 2 matrix, where the components now would be, so you just cross out first row, now it's going to be third column. Okay, so first row, third column is, okay, t squared, t minus 3, and we have et 0, so that would be k. Okay, now let's find the determinant of the 2 times 2 matrix. For the first item, which is the x component, that would be t times t minus 3 minus 0 times 3. Not very professional here, but I'm going to write it down anyway. And then we have minus. So here we have t squared times t minus 3 et. That would be the y component. And the z component would be t squared times 0 minus t minus 3 times et. So that would be the z component. Okay, now we're going to simplify this. So that would give us t squared minus 3t. So this is for the x component. For the y component, we have minus t cubed minus 3et. And for the z component, we have minus t minus 3et. Okay, so here I'm using summation of standard unit vector I, j, and k, or you can write it using the pointy bracket like so. Okay, let me erase this. Okay, next is the fourth item is where we need to find the dot product, I think. Yeah, the dot product between f and g. Okay, let's do that. The fourth is the dot product between f and g. So fourth is f dot g. So this is really vector f dot with vector function g. Okay, the result will give you a scalar. We don't have I and j anymore. Okay, first the components of vector f. That's ugly. For vector f, we have t squared I, t minus 3j, 3k, and the components of gt is eti, 0j, tk. Okay, so the result will give you a scalar. So what you do is you multiply the x component of vector f with the x component of vector function g, plus multiply the y component of f with the y component of g, plus multiply the z component of f with the z component of g. And then simplify them together, we get t squared et plus 3t. So you can see this is a scalar, not a vector. Just to refresh your memory on some operations involving two vector functions and also multiplication of vector functions with a scalar function like item 2. Okay, how are we doing with time? Yeah, we good? Okay, that's all. Thank you.